Hi everyone, welcome back to our last video on this page. So we've got number 36 here. We've got a rational that has a t and a t squared in the denominator. So I'm going to go ahead and say what t is not allowed to be, and let's pick out our LCM. This is another one where there's nothing that has to be factored in our denominators. So we're ready to do these two steps now. So because we have a t and a t squared, the only thing that t is not going to be allowed to be is 0. That's the only thing that would make our denominators undefined. So when we're picking out our LCM, and one of our fractions has a t and the other one has a t squared, we know we're going to need t squared in order to cross-reduce with both of those. So we're trying to pick the lowest common multiple that will cross-cancel with each of our denominators. So if I only had a t, it would cancel with this, but it would not fully cancel with the other one. A t squared is enough to do both. So we're going to go through, and we're going to multiply through. Whoops, I was going to erase that. Okay, we're going to multiply through the whole thing with a t squared. So I'm going to go and do my work on the side again. So I've got to do t squared times 3 over t. I've got to do t squared times 6 over t squared. And I've got to do t squared times 2. All right, so let's see what we get each time we do this. So a good thing to try on these is you could try pausing the video right now, seeing if you can get those terms so you can see where you're at. So when I do the t squared times 3 over t, this t on the bottom drops with one of these, right? Because this is t times t. So it drops with, I'm just going to drop the exponent. So I only have a t to the first power left. So when I multiply my two numerators that are left, I get a 3t. When I do the t squared times this fraction, the t squared drops with the t squared. Those cross cancel to 1, and 1 times 6 is 6. And then on the last one, the 2 didn't have a denominator, or it has a denominator of 1, so nothing cross cancels, and I get a 2t squared. So we're going to come up with our new equation now and see if it's linear or quadratic. Hopefully you can kind of see our terms and see what kind of equation is coming out of there. So we've got a 3t plus a 6, bring down my equals sign, and get a 2t squared. So I do have a quadratic, so I'm going to have to decide if I want to do it by factoring a quadratic formula. I'll have to see what's left here and see which way it works. So I'm going to bring everything. I think this one's easier. We want to leave this 2t squared positive. So I'm going to bring this over here, and I'm going to bring this over here. So I'm going to have a 0 equals 2t squared. That's going to be a minus 3t and a minus 6 when I subtract over the terms on the left to bring them to the right. So this one right here, it actually doesn't factor. I had looked at it ahead of time just to see, but you could try certain things. You could try the AC method, but nothing is actually going to work to get to, if you did the AC method, you would be looking for something that multiplies to negative 12 and combines to that negative 3. And no pairs work. So we're going to have to use the formula. Okay, so in this case, A will be 2, B will be negative 3, and C will be negative 6. So let's see, T is going to be opposite of B, so it's going to be a 3 plus or minus the square root of negative 3 squared minus 4 times A times C. Sorry, I didn't mean to run into that. All over 2 times A. I want to see if I can move up a little bit. There we go. Let me do a little bit more. Give us a little bit of room here. Okay. So let's keep going here. So now it's just really a matter of just keep simplifying, right? So we get t to b. All right, 3 plus or minus. Underneath our radical, we end up with a 9. And so over here, let's figure out, I always do the sign first. I say I have a negative and a negative, so I know it's going to be a positive there, under there. And then I just do the 4 times the 2 times the 6. All right, so I end up getting a 48. all over 4. Simplify again. We've got 3 plus or minus the square root of, and that is going to underneath the radical is going to combine to a 57, which is not a perfect square. Okay, so we have 2 solutions here. They're not rational, they're irrational because I have a radical left. It's safe to say that we don't have to worry about t being 0 here because that's not going to be a 0. So these are not extraneous. So my 2 solutions are t could be 3 minus square root of 57 all over 4, or t could be 3 plus square root of 57 all over 4. So depending on, I mean, those are exact answers. Once I go onto the calculator and do the square root of 57, I'll get an approximate answer. But I don't really have to unless my open math is specifically asking for a decimal for your answer, then these are okay. So I don't want you to feel like you have to. You really only have to change them into a decimal unless if my open math is asking for it. But these are actually nice exact answers when they're left in radical form. So we got 2 solutions from that because we had a quadratic, and we checked to make sure they weren't extraneous with what we said in the beginning, that t is not allowed to be. Okay, I hope these 4 videos helped a little bit, because since there wasn't as many in my open math for solving rationals, and I know this can be a tough section for people with, going through with the LCM and seeing what new equation is left. So let me know if you have any questions, and have a good rest of your week.